Hello. So as said, if you looked for the other talk, bad luck. It's me. I'm also going to be here later on talking about progressive web apps, but I filled in, and the organizers were nice enough to give me alcohol and use words and things, and it was very effective. So I started saying, okay, I can give another talk. I'm actually going to a Pixels camp after that in Portugal and give something similar there. So it's a good thing to try it out on a real audience. So I want to talk today about the image problem of the web, and not the image of the web, but images on the web, and how we can solve these issues with machine learning and also with just tooling that we think about, because there's far too many things on the web that we're not optimizing right now. And the problem is that we're sitting on these wonderful machines with fat connections, and we put things on the web and we think it's beautiful, and our end users basically stand there on a mobile phone with a spinning thing and see their data traffic in the background going there and their bank account going down, and they wonder what's going on. So I'm Chris Heilmann, a code poet on Twitter in case you need more pictures of kittens and hedgehogs, and some JavaScript stuff as well. I'm there pretty active there. This is me looking at mobile phones and being annoyed about the state of the web on mobile phones a few years ago. And luckily enough, this got a much better. I work for Microsoft on open source things like the JavaScript engine, Visual Studio Code, and also a little bit in the machine learning. But I'm more of a fanboy of the machine learning team and help them to talk to humans and humans to machine learning people. It's a bit like translating for programmers to other people, which is another skill that you should have. Let's go back in time a bit. We all know this character, right? If you know him in green, then you probably have an older sibling, because you were never allowed to play Mario, you always had to play Luigi. And what is funny about this character, and I used to do games on Commodore 64 and Game Boy Color and Amiga later on, is we always think like this limitation is because this is how it is. But there is sense and meaning in all of the things that is about Mario. First of all, the red and blue offer the best contrast to the skin, boots, and the game background. So they didn't put them together because they were the colors that were left over. They put them in there so you can see the character all the time. Nowadays, when people go for nostalgia of pixels, they don't understand that back then you never saw a pixel. We jumped over backwards to make sure you don't see pixels because it was bad TV sets. They smushed everything together. So you got to make sure that you have contrast between the different colors to make sure that your game character is visible. The cap meant there was no need to worry about hairstyle, eyebrows, or a forehead. Actually, originally Mario was not supposed to be a plumber. They just needed to make him a plumber because they didn't have enough pixels for the hair when he fell down a hole. So they just gave him a cap and then like, okay, who has caps? Plumbers. Okay, cool. We got these pipe sprites as well, so we might as well use those. And the large nose and the mustache made it possible to avoid a mouth and facial expressions because you just didn't have enough pixels for different facial expressions. And this is what the Mario was built for and what it was designed for. And it was great because it was designed by limitations. I always loved being creative in environments that are limited. And this is over. And back then, we fought for every pixel, fought for every piece of information, for every byte. But this is over because nowadays we got these massive machines, fast connections, we've got quad-core computers in our pockets, and we just don't understand that people on the other side of the planet might not be able to see that. So everything has reasons and meaning in that design that we did back then, whereas nowadays, evolution is happening around us. We're moving away from desktop machines to laptops and now actually to mobile phones. The next million users of the web will not be on any desktop or laptop. They will be on mobile devices. And the reason is infrastructure. In countries where there is growth on the internet, like Africa, Indonesia, Bangladesh, India, people don't have any flats where a computer could be set up. People can't afford a MacBook Pro. People can afford a mobile phone and a data connection. There's not even cables in the ground to get connectivity, but there is mobile masts everywhere, so everybody will be on mobile devices. So that's what we have to think about for the nearer future, or actually right now. This is where the next growth will be. And the next growth after that will not even have a UX anymore. It will just be chatbots and systems that people can talk to. So technology advanced. And pixels are a side product of our interactions with the web. Most people don't draw things on the web or make graphics, or they just take pictures and upload them. And they don't even caption them. They don't even explain what the picture is. They just let the picture speak for itself, which of course is incredibly depressing if you're a blind person and you get these pictures without any alternative text. You don't know what's going on. Or you're like an old person like me and you try to understand what Snapchat might be about and you're just like, I have no plan anymore what's going on here. These are people sending selfies to each other for the last 2 hours. What's the meaning of this? But okay, I'm old, fuck it. The problem is that we take pictures and we upload pictures and unoptimized pictures. The bigger the better. I mean, some of the phone that I have is like a 20 megapixel camera in it. This is like an 8 meg photo that I just upload in the background because my data plan in England is good enough to do it. I don't care about it. And if you look at the average website, and that is actually rather old, this is probably bigger right now. We can take a look at that later if you want to. It's 2.2 meg for a website. This is not for a web page. This is not the site. This is not the whole site. This is the first loading thing that people see on the screen. And it's 2.2 megabyte to say like, hello and welcome to our website. And this is the state that we're in right now because we kept pushing things on the web. You need these 12 libraries. You need these 15 JavaScript frameworks. And you upload images because they're pretty. And on iOS iPads in Retina, they need to look great. And everybody else should get the same picture. So it's 1.4 meg of images in that on the average web page out there. I call this inspirational obesity. We just put things in there because we see them pretty on our high-end devices, but our end users don't necessarily get them. They're just standing there and getting the loading spinner for 5 minutes, which is not a good experience. 1.4 megabyte of images, mostly because of wrong file formats. People save images as PNGs with alpha channel that don't need any alpha channel and would be happily a JPEG. Or a WebP if you have a browser that supports WebP. Or you have like text saved as JPEGs and it's unreadable, you know, without all the artifacts on it. It just drives me crazy that we just don't understand which format to use for which image, because most of the time people who upload images are maintenance coders. They're not developers, they're not designers, they're people that just use a content management system, drag and drop it in. You know, when you're a freelancer and you ask a client for a logo and you get a Word document with an embedded logo in it, and you just want to go back to goat farming and just, I don't want to live anymore. We're delivering scaled high-res images to everybody. We take a 6,000 pixel image and make it 200 pixel wide. I've seen that so many times. It's quite fun as well. And then people wonder when browsers are slow. No automatic conversion and optimization steps. We have all that technology, we just don't use it. We just have an upload facility, and even WordPress tells you can only upload 2 megabytes. So what does the good WordPress admin do? Turn that off and say like you can upload whatever you want. And then people have 20 megabyte images in there. Hero image instead of text content, that's very important. Web design lately is just this massive thing, and I blame Medium. You know, like instead of writing a long article, you got this massive image before you actually scroll and you're like, what did you want to tell me? This image is not you, is it? We need to change that to make the web fast again because connectivity is our biggest new hurdle. It's like for us here on wireless, this is actually an amazingly good for wireless for a conference, but most of the time you're on somewhere and your connectivity might be good, but the next second it might be gone. It might be a connectivity to a Wi-Fi connection that shows you, oh, I'm Wi-Fi, and then you can't connect it unless you give it your credit card details, your firstborn, some blood, and like your home address or something like that. Or sometimes you can't even connect it, although it gives you the full bar. It's called Li-Fi. The web is much bigger than our little developer world, and growth happens outside of it. If you want to think about the next few years of the web and you want to keep your job, think about those markets that you don't think about right now, because this is where growth happens. Everywhere else is on the decline. People don't actually download new apps. People don't use the web as much as they used to do. The big winners are people that stay inside Google services, inside Facebook services, inside Facebook services and Google services, and of course in chat systems like WhatsApp. One of these solutions that Google and Opera, for example, are really good at are cloud services and proxy browsers. So those actually used, for example, a lot in Africa and India, automatically strip down your images and automatically convert them to something really pixely and ugly, because it's better if somebody gets an ugly picture than no picture at all, if you relied on a picture for your content. And they also strip down your CSS and your JavaScript. If your JavaScript takes longer than 1.2 seconds to run on an old Android device, then it actually takes out your JavaScript. So if you relied on your JavaScript for your page to load, you're not lucky there. People will not see anything. But there are a few things we can do. There's a few things we can do instead of relying on these proxy browsers and hoping that Google fixes everything for us. So the problems with images are huge images for everybody, unoptimized images, no alternative content, no training or incentive to add content in content management systems, and here's our arsenal to fix that. I'm doing a bit faster because you said I have to do Q&A and stuff, so, but you're all clever, so it's all good. Better browsers with responsive image support are here right now, and we don't have to worry about these older browsers anymore. Automated lossless image optimization tools, file-level access to images to extract metadata, scripting solutions to offer alternative content, and cloud services, machine learning APIs for intelligent resizing. And I'm going to go through them bit by bit. Machine learning for tagging as well. So browsers with responsive image support. Responsive design should not be an unknown to people anymore. It's just a sensible thing to do. Because I have this, and I look at it like that, I turn it like that, then I switch to this one, and I switch to my Xbox, to my fridge, to my dog, to my cat, wherever the internet runs on nowadays. There is no screen size any longer. There is no thing, oh, we need 1024 pixels. It's like water. You put it anywhere in, it will fill as much as it can, and it's fine. So media queries were the first idea that we had with that in CSS and also in JavaScript with Match Media. The problem is with media queries, they're greedy. So if you actually have a CSS file with your large images in it, your mid images and your small images, the browser loads all of them and only shows the one that is appropriate. But the data in the background still gets used, and if you're on a metered data plan, that's a bad idea. That's why we invented the picture element and source set. Source set came from Apple. Picture element came from people who just looked at the video element and said, like, why don't we have a picture element? Because in this one, you define the image in several formats and several sizes, and the browser only loads the one that actually applies and doesn't touch the other ones. So that way, you have no problem of all the images being loaded. The support is great. This is, again, outdated. It's a bit updated now. I think Safari is now in the newest version. Caniuse.com is always your friend. If you want to try something new out, type it in there, be happy, and start using it. Don't complain that old browsers might die, because they have to die. Great information on Jake Archibald's blog, The Anatomy of Responsive Images, where he explains what all these source set shortcuts mean and what all the information is about. But in essence, most of the systems out there already use it. WordPress now uses it out of the box. If you just put an image in there, it does the picture element for you. There's also a great live demo on our Windows developer site, and that one shows you in a real-world scenario what that looks like. So that painting has been painted by one of our colleagues, by his wife, and shows you like that it only loads the image that is necessary for that size in the right format, instead of downloading lots and lots of data in the background and then resizing it accordingly. And you can play with that quite nicely to have a proper text to image ratio as well. Now, you have automated tools for lossless image optimization. That's very important. Lossy image optimization, you make your designers really unhappy, because you put like artifacts in there or get it down to like 12 colors instead of like 256. It's not fun to do that. Lossless optimization, a lot of times it's a packing algorithm that doesn't change the look and feel, but just goes on the byte level of the image and strips out the bytes that are not necessary and not needed, because Photoshop and other image editors put a lot of data into the file itself that you don't need. Image Optim is the big one there. If you don't use that yet, please use it. It's also available as an NPM module. You can also put it in your node solutions. And that one allows you just to drag images into it, and it automatically optimizes the images according to what it is. So a GIF gets optimized with one optimizer, a JPEG with another, a BMP, if you use it on the web, I'll come and hurt you. And other images, TIFF, for example, get also downsampled to a format that makes much more sense. And it's as easy as that. Just drag it in there, and it's replacing the original image. It's not making a new image that you then have to copy over or something. It just changes all the things in there that are not needed. And in this case, for example, we got 44% win on a JPEG. And this is as simple as it is. Before you put your images on the web, run it through a system like that, and everybody wins. Now, we have file-level access to information in images. We always had that in things like ImageMagick or GD library in PHP, but now we have it in JavaScript as well. We can use the EXIF data in the image itself. When you right-click something in Windows, it shows you the EXIF data where it's done. You can access that in JavaScript and do cool stuff with that as well. For example, instead of rotating a JPEG in the browser, you can actually read the header, and then it tells you what the rotation of the image is. So you already know that it's going to be displayed the right way before you turn it out. And 2012, when I used to work for Yahoo, we already played with that. We already worked with that in Flickr. And it was just amazing that we haven't thought of this in between. Because what Flickr, for example, did when I uploaded images is a pretty cool thing. You dragged it up there, and you show it in the browser, and the photos immediately show up. These are like all 8 megabyte pictures, and there was not a fast connection. So the photos show up quickly, and then they start uploading in the background. So if you take a look at this zoomed in, you can see that the image shows, and then you got the little circle thing there, uploading the image in the background. And this is using the EXIF data in the JPEG itself. Every JPEG has a little thumbnail in its file. So you can read the first 50 bytes and then display that as a thumbnail and then load the rest of it. So instead of loading it and then having an unload handler, you load it as a file reader, as a stream, and display it while you're actually showing it. And that is a great way to give an interface to your end users that looks much more interactive than just please wait. Of course, there's EXIF data in your pages as well that you don't want to give out. I created at removephoto.data.com, which works on a mobile phone, works offline, doesn't have any server at all, just works in JavaScript in your browser, where you can drag an image in and gets rid of all the EXIF data and gives you the image for downloading. So in case you don't want, for example, your geolocation in your image, or you don't want people to know which camera it was taken with, it's probably a good idea to do these kind of things. The geolocation is also visible in most of the JPEGs that you do nowadays with cameras, and I can tell you where the picture has been taken. And that has been the downfall for a few people that want to harass other people with pictures of parts of their anatomy, and then they actually found them because they realized where they lived, which is good. But you should actually make sure that if you don't want to give that data out there, be sure that it's actually not in your JPEG file anymore. So a good thing about an interface with images is to provide fallback content. So instead of just waiting for the image to load, you could, for example, give a colored background that is part of the image and then gets replaced when the image has been loaded. A lot of systems use that nowadays already. The blur up technique is a big one. You can see this one, for example, here. Let me start that again, where you see the image being blurry and then becoming sorted. This is on Medium. Medium uses that, for example. And on Medium, this is the code for it. And this is pretty much nuts. You know, it's like a figure with 10,000 diffs in there and a JavaScript and an image progressive media, blah, whatever. I don't know what's going on there. And which is, it looks good, but I don't know why they do it that way, because there is a CSS technique to do the same thing. So what you do is you take this much smaller image of that one, like the thumbnail that is embedded in the JPEG, and you scale it up in CSS with 100% with the auto width of the container, and set a CSS blur filter on it or an SVG blur filter over it. And then when the full image has been loaded, you just turn off the filter and you get rid of the small thumbnail image. And that way you get the same effect without having to jump through hoops of like 10,000 lines of JavaScript. But it looks good. It gives the impression that something is happening, and you cannot do nothing worse than making people just wait. People don't like waiting, and especially not on a mobile device. So this is a great way of making that work. You can also count pixels. In Canvas, I have full access to every image in the browser nowadays. I can't have access to an image on another domain because there's a security problem in there. But if I drag and drop an image, for example, into the browser, or I have the image already on the same domain, I get pixel level access to the image itself. So if I put it in the canvas and read out the canvas data is an object with the width and the height, and then it's an array of 4 elements, which is like the RGB and the A value of each of the pixels. So for example, in this case here, I have this little C64 text thing, and I just count the pixels and tell you there's 10,472 black ones, so that's probably the main color that I want to use here. And you can use that to determine which are the colors that are there, but there's better ways of doing it. But this is a nice way, a simple way of doing it. And this is the code, so just note that down quickly now. The slides are available later on as well. There's lots of tools that use this kind of functionality as well. There's colorify.js, which uses the gradients as a background and find out the right color for you. It has a lazy reveal as well, so you can load them and fade it in from the image to from the color to the image and so on and so forth. And you got Color Thief, which is really, really cute. Because that one allows you to, like, for example, click, this is a demo here. So it clicks on the image, it finds the dominant color, and it finds the palette of it as well. So this is cool to basically have an image and show CSS stuff around it that it is the right palette and the right kind of color according to that image. And that's, again, a JavaScript library you can use for that. Now, let's go to the nitty-gritty of like what we can do with computers nowadays about images, and this is where I'm getting very excited what we can do, which is, for example, intelligent image resizing. So to have a thumbnail of that image would normally be like, let's take that massive image and make it 150 pixels wide, and you have like a few pixels on the left that might be a woman and lots of blue pixels on the right that we don't need. So instead, what we do is we detect, okay, where this would be the normal way to cut out 150 by 150 in there. It's nice, but it's not good enough. This one is much better because what we did is we detected the face of the lady, and then we actually centered it on the thing and cut the rest out. And this one is the best because we detected in the image the outline of that person and then actually cut only that one out. So this is something that you do by hand in Photoshop or something, but machines can do quite nicely nowadays as well. And it makes much more sense to have something like that displayed in your website than something that, that is just a blurry mess and you don't know what's going on there and you don't want to click on every thumbnail. And please, never ever resize an image to become a thumbnail. The idea of a thumbnail is it's a preview of the image both in file size and in size, not only in size. I see so many people downloading 50 megabyte pictures and show them as 100 by 100, and when you click on them, look, it's really fast because it's already loaded. Yeah, 20 megabyte are downloaded, I only want to watch one of them. There's a JavaScript library called SmartCrop.js that explains you how to do these things. It's kind of heavy on the machine, so on a desktop machine, fine. On a mobile phone, please don't run this kind of stuff because it's not meant for doing that, and you don't want to fry eggs on your back of your phone just to have a nice thumbnail. So you see in this case, in this case, it found the outlines of the man and then the crop around it, and then that way it found the right size. So it determines what the outlines are, and depending on how close they are to each other, it realized this is the most important part of that image. There is a company called Cloudinary that are using our systems under the hood, and a few others as well in Israel. They're really adamant right now to tell you about their stuff, but they're really lovely people. I was in Israel a few days ago and I talked to them. And what they do is they give you a URL API, like a REST API. So you can say restcloudinary.com, and then you have your image, the uploaded image, and then you say, okay, give me a 16 by 9 ratio, make it 640 pixels wide of the on-the-phone JPEG. So this one now realizes, okay, it's 16 by 9, it cropped it to 16 by 9, and it made it 640 pixels wide of the image that you uploaded. This is kind of cryptic, but they're actually making it much more easier for you by having a proper SDK, and as you can see, almost every language out there, Ruby, PHP, Python, Node.js, Java, whatever. And that one allows for intelligent resizing of images. So when you now resize the browser, it gives you the image that uses the best space, and if you're on the right-hand side, you can see that the images show more and less, but keep the people in the middle of it because they center on the face. So that way you can automatically art direct your images without having to crop them by hand because the machine learning algorithm does that for you and understands that for you. ImageX is another service that actually does that, and they're even getting better. They're not only using facial detection, which is like eye, nose, mouth, but they're also doing a high contrast version of your image, and that way find out the most important parts. So the same here, they're doing the outlines and the high image and then crop the rest that doesn't have enough contrast, and that also works that way. So what about information that isn't in the image? This is basically what you can do with the image itself. But what if we want to know that this is a coffee mug and this is like, or this was like the current president of the United States in that image, and we don't want to have to know that? Machine learning and artificial intelligence to the rescue. Robots and computers are there to plow through data and oodles of data without getting bored. And this is the good thing about computers. This is what we should be using them for. So Facebook has, for example, an automated alternative text. This is a photo a friend of mine uploaded, and it says image may contain. So there you see that it's actually automatically generated. Dog, outdoor nature, and you can see it in the alternative text on the image itself here as well. If you're in the developer tools here, in this case, Firefox. How do they know that? Do they have like people in the basement chained to a desk that actually have to type these things in? Maybe. I don't know. But I think most of the time they use computers for that. It's not Mechanical Turk anymore. That used to be the thing in Amazon to do these kind of things. So there's a great blog post on the Facebook code blog that explains how they've been doing that for years and years. Like all the images that are in Facebook have been analyzed, have been classified, have been detected, and have been segregated or segmented into different sections. So here you say like, okay, I've got sheep, I've got dog, I've got man, and then you find all the sheep, the dog, and the man, and you segment them out, and that way you have it in the database. If something looks a bit like that, it's probably a sheep from behind. And they do that with all kind of data that they have on Facebook images already, and now finally they gave us access to that one as well on a programmatic level, that we can use that for our implementations as well. So it's not that they just are evil and find our data, they're giving it out as well, which is pretty good. And Google has been doing that on Google Photos for quite a while as well. I showed that the other day in Germany. Like my photos, I don't type any German. I only type English. But for example, you can click on selfies in Google Photos and automatically finds the pictures that are selfies without you ever having to type in that this was a selfie. So this was at Smashing Conf and another conference, and it's basically me with a hedgehog and these kind of things. And it also finds locations for you. So I say, for example, Tel Aviv, and it doesn't only use the JPEG data of Tel Aviv, but this is, for example, Heathrow, on my way on the flight to Tel Aviv. So I don't really know how they did that, but it is the right photo. And the pictures of these emojis and these kind of things are all done in Tel Aviv as well. I can then say Hund, which is dog in German. I've never entered that, ever. But I have uploaded pictures of dogs, and cat for cat, Katze for cat. It detects my family's dog as a cat, which is true because he behaves like one. But I don't know. Sometimes it's not as good as it thinks it is. But it's pretty amazing that you have all this cool information in there without having to type it. So the data behind that is from databases that have been used for years and years to classify and tag images. There's ImageNet, for example, which is 14 million images right now. And that one gives you a database to compare your images against and to find the right solutions that this is a cat, this is a dog, and so on and so forth. Google just last week released the Open Images dataset, and that's over 9 million URLs of images that are tagged and classified for you. So you can use that CSV, it's on GitHub, and with the metadata that you can download and run it against your own learning services to understand what your images might have in them. And this one has, for example, this picture, the balcony, stairs, facade, iron, and so on. And it's not like just like that's a spoon and that's a fork. It has lots of information in there that is highly detailed that you could then, for example, run through a translation service to find like the Danish dog or the Danish dog is like those big ones, but that's a different story. They also have they run these tags then through a language compiler, and we do that as well with a few of our services. So image captioning, it's open sourced in TensorFlow, and you can use that. And what they use it for is mostly for the Google Photos, but also the upcoming Allo chat client that they're doing. So in this case, they have like human captions from the training set, which is like a man riding a wave on top of a surfboard, and the automatically captured one is finding 3 different images from that. So they take whole sentences from that data set rather than just having a tag saying surfboard, man, wave, which is not human readable and not beautiful. They also then do syntax detection on these things and find the nouns and find the attributes and mix and match them to make better captions for other things afterwards. And they also then take it together with the image data. And for example, instead of saying like there's a train with a Union Jack on the side, it says like it's a blue and yellow train because it also detected, again, how many pixels are blue and how many are yellow. And there's 2 brown bears as well instead of just 2 bears. And what they use it for is for Allo, where basically you upload an image and you get these automated tags that if you don't want to type something in, you can just type that on there, which is pretty cool, but I find it really bizarre. Doesn't that mean in the end that we as humans just become a transportation service from 2 bots to talk to each other? Because I'd rather have you type something in and mistype it and make it human than just give me like, oh, friend, robot, answer kind of thing. You know, it's like, it's really odd, but people seem to be too lazy to type shit in, so they want that, fine. We have something like that as well called CaptionBot, which is using 3 of our services. So all of these services are available. Google's TensorFlow, Facebook's whatever it's called. Amazon has a few things in their Alexa systems or pure Alexa skills. And we have the Microsoft Cognitive Services that you can play with where you get 5,000 hits a month. And then you can pay for more later on. So this one is, you upload an image. You can try it out at captionbot.ai. Analyzes the image and says, I think it's a young man jumping in the air on a skateboard. And you see there, we don't have man skateboard young. We basically have a whole sentence because we ran it through a language analysis tool in machine learning as well to give you a sentence at the end. Now, detecting humans is a very important thing as well. One of our services does that for you. So it realizes this is a 28-year-old man, a man in water swimming. And it also tells you, if you scroll down, I don't have that animated this time, and I don't have it live here right now, it also finds the colors for you. And it realizes if it's a racy photo or if it's an adult content photo. So before you upload, then you can automatically do that. The other service that we have is automatically detecting child pornography. In case you have an open system that you allow anyone to upload anything, you don't want that to be abused by the most horrible people on the internet. You can do that. You can run it through that service before and automatically flags and deletes images that have been already recognized as totally illegal content. And that way we protect both the people that had these pictures taken of them and you from persecution because we actually find out who's been uploading them. For example, the lady down here in the bikini will be flagged as racy, but not as adult. And this one will find out train and train station and all kind of things. This is city line. So the images are there to find the information in, but mostly once we detect the face, we also guess the age and we also give you the gender. Once we have a face, we also give it an ID in your data set, so you can try that out for yourself for example, verification or login systems, or detecting if the same person is in 2 different images and then automatically clustering them into different folders. We also have emotion detection, so we detect, for example, that the man here is kind of happy, but he's also, what else is there? He's a bit of fear. No, the kid. The kid has a bit of fear and is a bit of neutral and a bit of surprise. So his mouth being open. Sadly enough, I didn't bring it with me. Normally in our booth, I have this demo where you have to show all the different emotions and then you can win a prize, which is pretty pointless to try in Finland, but from time to time it's fun to see what computers think our different emotions are and our different states of emotions are. So you can detect the faces, you get the JPEG, you get the JSON back, and that is basically just a REST API that you can throw an image against. And you find out the pupil left, the pupil right, and the age, and what the head pose is, like which angle to put the faces on. So when you do, for example, login, you don't just do it with one face. You have to ask the person to change it so you can see it's a 3D face and not somebody holding up a picture of you to log into your computer. You can verify the face. Once we know it, is that the same person? No, it's obviously not the same person. You can cluster them into different clusters automatically. So these are men, these are women, these are in-betweens, these are I don't know today kind of things. And the great thing is that putting these all together, you can really empower people. And there's where I want to show you a quick video that a colleague of mine has done. And it's pretty stunning. So let's just watch that quickly together.
I'm Saqib Sheikh. I lost my sight when I was 7, and shortly after that I went to a school for the blind, and that's where I was introduced to talking computers, and that really opened up a whole new world of opportunities. I joined Microsoft 10 years ago as a software engineer. I love making things which improve people's lives. And one of the things I've always dreamt of since I was at university was this idea of something that could tell you at any moment what's going on around you.
I think it's a man jumping in the air doing a trick on a skateboard.
I teamed up with like-minded engineers to make an app which lets you know who and what is around you. It's based on top of the Microsoft Intelligence APIs, which makes it so much easier to make this kind of thing. The app runs on smartphones, but also on the Pivot Head smart glasses. When you're talking to a bigger group, sometimes you can talk and there's no response, and you think, is everyone listening really well, or are they half asleep? And you never know.
I see two faces, 40-year-old man with a beard looking surprised, 20-year-old woman looking happy.
The app can describe the general age and gender of the people around me and what their emotions are, which is incredible. One of the things that's most useful about the app is the ability to read out text.
Hello, good afternoon. Here's your menu.
Great, thank you. I can use the app on my phone to take a picture of the menu, and it's going to guide me on how to take that correct photo.
Move camera to the bottom right and away from the document.
And then it'll recognize the text. Read me the headings.
I see appetizers, salads, paninis, pizzas, pastas.
Years ago, this was science fiction. I never thought it would be something that you could actually do. But artificial intelligence is improving at an ever faster rate, and I'm really excited to see where we can take this. As engineers, we're always standing on the shoulders of giants, building on top of what went before. And in this case, we've taken years of research from Microsoft Research to pull this off.
I think it's a young girl throwing an orange frisbee in the park.
For me, it's about taking that far-off dream and building it one step at a time. I think this is just the beginning.
How cool is that? I mean, it just fascinates me that he's like an engineer himself writing this. And I sat next to a blind PHP engineer for years who was much faster than me coding, and I was just confused about this. But it's so much insightful when you actually do that kind of attitude. And what I love about machine learning is that people with disabilities are the superhumans to test against. If it works for them, then it works for us even better. And that's the really, really cool way of, I've been doing accessibility for years and years and trying to make people understand that disability is not the end of things, but it actually is an opportunity for everybody. And with inclusive design ideas and this kind of thinking, we have a great opportunity to make things understandable for everybody who doesn't, for example, see or isn't able to understand it or take a picture of something. If you've seen, for example, Google Translate on a phone as well, the app, you can just take a picture, you can turn your camera on and see a street sign, and it translates it live for you from the camera. And I mean, how freaking cool is that when you're in Russia and you don't know what the name of that street is and you only have the English name, for example. And these things are all possible because we have these massive amounts of data. And what I love about this example as well is that it's all open data. It's like he just used the open APIs from Microsoft. He didn't have any internal access that gave him extra access or something like that because we didn't build those, sadly enough. But he just built that for himself with systems that are open, and he's now going to release it on iPhone, I think, first. And I think this is pretty amazing when you compare it to the other services that are out there. I was just at an accessibility conference where there was a commercial company showing the same thing. Oh, we got glasses that can detect people and tell you when they're in the room. And it was €4,500 for those glasses. And that whole solution can run on any smartphone right now, and you don't need those extra glasses to get the same functionality. And that's what I want you to think about when it comes to this machine learning in images stuff. The APIs are out there. There's trillions of photos that we already indexed for you. So cross-reference your own data and make your images more accessible that way. And that's all I had for now, so thank you very much.